Hi guys, it's Daniel here, and believe it or not, this is actually our 128th video. And since 128 is a power of 2 to the power of 7, I wanted to celebrate by doing a problem that had to do with powers of 2 and powers of 5. This is 2012 AMC 10A problem number 25. So let's first read the problem. The number 5 to the power of 867 is between 2 to the power of 2013 and 2 to the power of 2014. How many pairs of integers m, n are there such that 1 is less than m less than 2012 and 5 to the power of n less than 2 to the power of m less than 2 to the power of m plus 2 less than 5 to the power of m plus 1? So first, let's try to decode what the problem is really asking. So this inequality right here, what does this actually mean? Well, it just means that we have powers of 5 from 5 to the power of n minus 1, 5 to the power of n, 5 to the power of n plus 1. And then we also have powers of 2 dispersed among these powers of 5. For example, we might have 2 to the m minus 1 located here. We might have 2 to the m located here. We might have 2 to the m plus 1 located between 5 to the power of n and 5 to the power of n plus 1. And we might have 2 to the m plus 2 also located between 5 to the power of n and 5 to the power of n plus 1. So basically what the problem's saying is, how many times does it occur where m is between 1 and 2012 such that there are 3 consecutive powers of 2 between 2 consecutive powers of 5. So now that we know what the problem is asking, let's consider what this information and this information can tell us. Because this first piece of information seems kind of weird. 5 to the power of 867, some random number, is between these two random numbers. And then this also seems like an arbitrary bound. So if we look at these two together, it might give us a clue on what exactly we are supposed to do. So it says that we want to consider all m less than 2012. And where else can we see this? Well, it's kind of close to this part, 2013 and 2014. It's just off by 1 or 2. And then when we look at over here, if we plug in m into our inequality, it states that 5 to the power of n is less than 2 to the power of 2012 less than 2 to the power of 2014 less than 5 to the power of n plus 1. So actually, just using the weird information that we started with, we can already get some information. That is, that in this case, 2 to the 2014 is less than 5 to the power of 867. So that means out of all the powers of 5 that we're considering, we don't need to go over the 867th power of 5, since we're only considering m between 1 and 2012. So now, all we need to do is count between 5 to the power of, let's see, can 0 work? Well, yes, because this is integers, it doesn't need to be positive integers. So from n equals 0, so in other words, 5 equals 0, 5 equals 1, or it's 5 to the power of 1, all the way to 5 to the power of 867. Out of these powers of 5, after we insert a bunch of 2 to the power of stuff, powers of 2, how many times does these powers of 2 appear in 3 in a row between 2 consecutive powers of 5? That is our new question. And how might we solve this? Well, first, it might help us to analyze exactly when does 3 powers of 2 happen between 2 consecutive powers of 5. And also, what other possible values, number of consecutive powers of 2, can we even have between 2 consecutive powers of 5? So, some small cases might give us some insight on this. So let's start on the side. Let's just list out some values. 5 to the power of 0, 5 to the power of 1, 5 to the power of 2, 5 to the power of 3, 5 to the power of 4. I think this is enough. Let's see, 1, 5, 25, 125, and 625. Now let's list some powers of 2. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and so on like that. So let's consider when how how many powers of 2 we have between each consecutive power of 5. So in this case, we have that 2 and 4 are between 1 and 5, and then 8, 16 and between 5 and 25. 32, 64 is between 25 and 125. 128, 256, and 512 is between 125 and 625, and so on like that. So it seems to us that there can only be either 2 consecutive powers of 2 between 2 consecutive powers of 5, or 3 consecutive powers of 2 in between 2 consecutive powers of 5. So let's set on actually proving this. So let's suppose that we have a power of 2, well, power of 5, 5 to the power of n, and then a power of 2, 2 to the power of n, power of 2 to the n plus 1, power of 5, 5 to the n plus 1. Okay, let's put another one here. So now the question is, where can we place this 5 to the power of n plus 1? Can we place it here, or 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 even here? 2 to the n plus 3. So, first of all, can we place it right here? Right here. Well, if we look at 2 to the n minus 1, which is less than 5 to the power of n, and then look at 2 to the power of n, well, if we multiply by 2, we get to from 2 to the power of n minus 1 to 2 to the m. But then, in order for 5 to the n plus 1 be between these two, we need to multiply by 5. So if multiplying by 5 goes a shorter distance than multiplying by 2, well, that's obviously a contradiction, so this path won't work. So now let's consider this next one. Is this possible? Well, we have that 2 to the n minus 1 multiplied by 4 gets to the n plus 1. Yet 5 to the n multiplied by 5 still gets a smaller distance away. It increases by a smaller distance. So clearly this is also a contradiction, since multiplying 4 can't increase by a larger amount than multiplying by 5. So this is also not possible. So is this one possible? Well, let's consider if we multiply by 5, we get from 5 to the n to 5 to the n plus 1. But right here, multiplying by 8 only gets us from 2 to the n to the n plus 3. So in this case, we have that multiplying by 5 gives us a larger increase than multiplying by 8, which is also a contradiction. So this path won't work. And clearly anything to the left of here or to the right of here, all of these won't work anymore. So that means the only 2 possible cases that actually do work is 5 to the n plus 1 located at this place, or 5 to the n plus 1 located at this place. In other words, we can either have 2 powers of 2 between consecutive powers of 5, or we can have 3 powers of 2 between 2 consecutive powers of 5. So that means we have just proved this conjecture that between every 2 consecutive powers of 5, there's either 2 consecutive or 3 consecutive powers of 2. So now, equipped with this knowledge, we can try to solve the original problem. So in each case, we can either have 2, or we can either have 3 between each consecutive power of 5. So let's let the number of times that 2 consecutive powers of 2 happens between 2 consecutive powers of 5 be A. And let the number of times that 3 consecutive powers of 2 happen between 2 consecutive powers of 5 be B. So what do we know about A and B? Well, first off, because we know that each consecutive power of 2 consecutive powers of 2 or 3 consecutive powers of 2 happen between 2 consecutive powers of 5, and there are a total of 867 times where we can look between 2 consecutive powers of 5, then that means we know that A plus B is 867. Then we know that for each A, we contribute 2 powers of 2. For each B, we contribute 3 powers of 2. Then we know that 2A plus 3B is equal to the number of powers of 2 that is between these numbers, which is, knowing this information, 587 is between 2 to the power of 2013 and 2 to the power of 2014, is equal to, well, we can have 2 to the 0 all the way to 2 to the 2013, except for note that we actually can't have 2 to the power of 0 because that's equal to 1, which is actually equal to 5 to the power of 0. So 2 to the power of 0 is all by its lonesome right here, along with 5 to the power of 0. But everything else is actually between the powers of 5. So 2 to the power of 0 doesn't work, so it's actually between 2 to the power of 1 and 2 to the power of 2013. So 2a plus 3b is equal to 2013. Now, if we solve this, 2 to the a plus 2 to the b is equal to, let's see, 1734, which means that b is equal to, let's see, 972, 279. And is this what we want to find? Well, we want to find how many pairs of integers such that this is true, which again, we've already said, is when 3 consecutive powers of 2 is between 2 consecutive powers of 5, which is actually what our b calculates. So this is our final answer, and we are done.
Hey guys, I'm here back with another math video. Today we're going to be doing 2016 AMC 12B, problem 25, since AMC is coming up.